Hello everyone, and today we are going to discuss about today's Leetcode problem. So if you are new to our channel, please do subscribe our channel and let's move to the problem. Okay, let me open the OneNote. So let me read the problem. Single number third. So you have been given an integer array nums in which exactly two elements appear only once and all the other elements appear exactly twice. So remember that it is exactly twice. So you have been given one array nums that contains the integer only. Apart from that, only two elements that appear only one. Let's say 1 and 3 that appears only once, and all the other remaining element appears twice. So you can see if it is 2, then here also 2, 4, 4, like that. So you can clearly see that only two elements, 1 and 3, are appeared only once. All have duplicate, and it should be exactly twice. Okay. You can return the answer in any order. So you will have answer as array of length 2. You can say 1 and 3 because these two appears only once. So you must write an algorithm that runs in linear runtime complexity that we can say order of n and uses only constant extra space. So we can say order of n or order of c. Okay. So let's move to the example first. So in this example, you can clearly see that 1 is repeated and 2 is also repeated. So our answer is 3 and 5. Now here both are appeared only once. So that would be our answer 0 and 1. So this is the problem statement. Now we will move to our solution. So as usual, we will first discuss about the brute force solution. So brute force solution mainly contains like you can use loops, you know. So now you have been given one array, let's say 1, 2 and 1, 3 and 2 as well and 5 as well. Okay. I think 1 is repeated twice and okay. So this is the valid array. This is the nums array. Okay. So now what I can do is I could use the loops in brute force approach. So what I will do is I will pick the 1 and I will check in the array like what is the count of 1 in the array. If it is 1, so it will not be our answer. Now I will move to 2. I will check the count of the 2 in this array. If that is 2, I will not count it as answer. Again 1 and 3, the count would be here 1, so that I will add this into my answer. I could say nums 0 would be 1. And then again 2, count is 2. Again 5, the count is 1. I can add this into my nums 1 as 5. I think here it should be 3. So now I will just return, I will just return my array as 3 and 5. I will not write the code for this approach, but you can clearly see that we are using two loops here. Okay, now let's discuss about the time and space complexity. Here, time complexity would be order of n square and space complexity would be order of 1. Okay, but in question, he says that we need to do that in order of n. Okay, you can use here constant extra space, but it should not also, it should not be order of n. Anyway, now since you can clearly see that all we want is like what is the count of the number in the array. For 1, let's say it is 2, and for 2 it is a 2, for 3 it is a 1, for 5 it is a 1. Then we can clearly see that here we can use Hashmap here. So what Hashmap will do is, I think everybody knows about the Hashmap. If you are a beginner, then I would say go check it out, the Hashmap. Hashmap is the key value data structure where you can see, let's say your key is the element and value would be how much time it is repeated. So let's say it is repeated 2 times, then 2, it is repeated 2 times, then 3, it is repeated 1 times, then 5, it is repeated 1 times. So here you can clearly see that these are the count of 3 and 5 is 1. So that would be our answer. So you can do that in using map. So under the hood, map is basically an array only, you can say. The key you can consider it as index, and value you can consider it as a value on that particular index. So that is under the hood implementation. If someone talks about that, how the Hashmap works, then you can tell him like how it is working. But that is not our concern here. We just want that we use the map here to store the frequency. Okay. And if count of frequency is 2, then it cannot be our answer. If it is 1, then it would be our answer. Again, I will not write the code for this one as well, but I will discuss the time and space complexity. That would be order of n, and space also would be order of n in this case. Okay. Now, again, we meet the time requirement, but again, we need to reduce the space as well. He said that we need to do that in constant space. So here, this will not work. Okay. So now we will move to our optimization approach. But before moving to optimization approach, I just want to discuss some other things as well, so that you can clearly understand the optimization approach. So since the question is to find two elements that appears only once, okay, and others are repeated twice. Now, if you know the JOR properties, so let's discuss the JOR properties. What it says, if you JOR the element with the 0, you will get the same element. So this is the first JOR properties. Okay. Now, second JOR property is, if you JOR the element by itself, you will get the 0. So let's say you have 3 and you have JOR it with 0, then you will get the 3. Okay. And this is also the symbol of JOR. And if you JOR 3 with 3 itself, you will get the 0. This is the second property. You don't need to remember the name. If you want, you can, but all I want is you just understand the concept here. Then commutative property, it says if you JOR 3 with 4, then the answer would be same as 4 JOR 3. Obviously, that should be the same. 3 and 4 JOR and 4 and 3 JOR, both are same. Then another property is associative property. It means if you JOR 3 or 4 and 5 JOR, it would be same as 3 and 4 JOR and 5. So it just clearly say it doesn't matter like in what order you JOR, but if you JOR all these, that you would get the same result. So grouping of JOR element operation doesn't matter. This is the, I think, fourth property. Now, fifth property, it says if you JOR 3 with 4 and 4, then you will get 3. Why? Because here we already say that if you JOR with same element, you will get the 0. So here you will get the 0, and 3 JOR 0, we already see that would be 3. So from these 5 property, only thing you should remember is that if a number is JORed with itself, it will get cancelled out and it will result in 0. Just remember this one. Just remember this one. You don't need to remember any of the properties, but remember this property. If you JOR 2 elements and both are same, you will get the result as 0. Okay. So that's about the JOR properties. Okay. So before moving to our original problem, I want to discuss some other problem so that we can easily solve that problem. Now the problem is single number. Let's first read it. You have been given an, okay. So if you think like I'm wasting your time, you can directly jump to the solution at the end. But if you want to really understand how things work, then continue the video. So you have been given an non-empty array of integer nums. Every element appear twice except for one. Find that single one. So this is little bit different. Here it says that all the elements are repeated twice except only the one. Now, I want to tell you that if you JOR the whole array, what would happen? If you JOR the whole array, what do you think would happen? Obviously, 2 and 2 JOR would result in 0. 3 and 3 JOR would result in 0. Only thing that would remember would be the 1. And that is your answer. That is your answer. So this is the solution of the problem. You JOR the whole array and you will get the answer. You JOR the whole array, you will get the answer. You will JOR the whole array, you will get the answer. Now come to the next question. That is missing number. So I would require your little bit attention here. So you have been given an array nums containing n distinct number in the range 0 to n. Return the only number in the range that is missing from the array. Okay. So n distinct in numbers in the range 0 to n. Okay. 0 to n, how many numbers are there? obviously n plus 1. But the size of array is n. So one element is missing. One element is missing. But the array contains all the distinct element. All the distinct element. So this problem is really interesting. Why? Let's say you join all the element between 0, 1, 2, and 3, and 4 till n. Okay. Then you join with the array element. That would be also 0, 1, 2, 3. But one of them would be missing. Let's say I call it missing till n. Now, closely see this. You can see 0 would cancel 0, 1 would cancel 1, 2 would cancel 2, 3 would cancel 3, and 4 would cancel 4 if there is. But there is one element that is missing, and that element won't find pair. Won't find pair. If that won't find pair, then what would happen to him? That would be our answer. That would be our missing element. And that is our answer as well. So here you can clearly see that we join all 0 to n and all the array element. This is array element and this is 0 to n. So in array, one of the element is missing. So it will not get any pair, and that would be our result as well. So I hope you get it. Let's see this example. So n is 2 here. So what I will do is 0, 1 and 2. Then I will join it with my array. You can clearly see 0 and 0 would cancel, 1 and 1 would cancel, and it would return our 2 as answer because 2 didn't get any pair because it is missing in the array. Now let's check this one. N is 3, then 0, 1, 2 and 3. And now let's see the array element 0 and 1. You can see 0 would cancel 0, 3 would cancel 3, 1 would cancel 1, and my answer would be 2 here as well. So you can see how JOR is more powerful. You can clearly see that. Now move to the one more problem, and then we will continue our original problem. Find the duplicate number. You have been given an array of integer nums containing n plus 1 integer, where each integer is in the range 1 to n. There is only one repeated number in nums. Return this repeated number. Okay. So given an array of nums containing n plus 1 integer, where each integer in the range 1 to n. Okay. So 1 to n is the range, and the size of array is n plus 1. So we can see all the element it will contain is 1 to n, but one more element that is we can say duplicated. Okay. Now let's say you join it with 1, 2, 3 till n, then don't you think you will get the duplicate? I mean, it is very simple, na? Like it will cancel 1, 2, 3 till n, it will cancel. This is our 1 to n, and this is our array. So one of the element is duplicated, and it will not find a pair here. So that would be our result. So here we can say you join with 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. N plus, okay. So that would be till 4 only, na? The size is n plus 1. So that would be 1, 2, 3, 4. So 1 would cancel 1, 2 would cancel 2, 3 would cancel 3, 4 would cancel 4, 1, 2 would be there. And that would be our answer. So that's all about the, JOR operation. I hope you get the better understanding of the JOR operation here. So now let's just move to our original problem. So where you have been given like 1, 2, 3, and 4, and 3, and 5. Okay. Now you join all the element. What you will get like 2 would cancel 2, 1 would cancel 1, 3 would cancel 3. You can see there are two number that is remaining. Let's say I call it X and Y, and that is our answer as well. Remember that X and Y. You will get the JOR, because we are doing the JOR of all the element. So you will get the jour of x and y. That is, let's say, your answer. Now, one really interesting thing that you could, understand here is, let's say you have the answer as 5. Let's just say answer as 5. It is nothing but x, jour, and y. Now, what would be the binary representation of 5? That would be 1, 1, and 0. Okay. Now, this one, what is the significance of this one or this one? What is the significance? If I tell you the jour properties, when you have the same element, you will get the 0. Like 0 and 0, you will get 0. But if you have different element, then you will get the 1. Now, this one signifies that at this bit position, either x contain 1 or y contain 1. Both can't have. Both can't contain 1 because if this is 1, it just means that either of the condition is possible. Either x is holding 1 at this bit position or y is holding bit at this position. Now, you probably wondering like, what about the other element? What about the other element? Why we are not considering them? Because at this position, you can see all would have the pair. All would have pair and that would cancel out each other's here. All that would remaining is x and y. So if this bit position contains 1, it just means that either x contains or either y contains the bit as 1. Then what I will do is, based on this bit position, bit position, I will partition my array into 2 groups. Okay. So let's pick one real example. 1, 2, 1, and 3. Let's pick this one only. So if you jour the whole array, what you will get 2 jour 3. And what is the 2 jour 3? That would be 1. That would be 1. So partition the array where you can see the bit position at this is 1. So you can say 1 would be in this group. 2 is 1 and 0, but we need 1 at this position. So 2 would be in different group. Now 1 would be here, 3 would be here. But if you jour this group and if you jour this group separately, you can see it would be cancelled out and you will get 3 here and you will get 2 here. And that is our answer as well. So you can clearly see like how interesting this problem was. Like based on the bit position, one of the bit position, you can pick this bit position as well and you can pick this bit position as well. But it is very easy and to get this lowest bit position. So once you get the bit position, you can partition your array based on the bit position, and then you will get your result. So I think that's all. But how would you get the bit position? Let's say you have 1, 0, 1, 0, 1, 1, 0. Let's say make it 0 as well. Make it 0. Okay. So this is your n. What I want is the one at here only. So the thing is, let's say you invert it. You invert the bit, then you will get 0, 1, 0, 1, 0, 1, and 1. Now, since you invert the bit, you can clearly see if all these have 0, all these would have 1. Okay. Now, if you add 1 here, what it will do is, it will set the first 0 as 1. 0, 1, 1, 0, and 0. So this is, I think, let me erase it. that would be invert n plus 1. This is, and why this is working plus 1? So I just want to tell you, like, the representation 1 0 and then 1 1 0 0. Then once you have 1 1, then you start with 1 0 0 1 0 1 1 1 0 1 1 1. Once you have all ones, if you add 1, you will get 1 0 0. So you can see it just increased 1 bit here and all these had 0. So if you add 1, you will get the first 0 bit as 1 and rest of these bit at 0. So now if you add this and this, you can see 0 and 0 would be 0 and all others are already inverted. Inverted means their end would result into 0. So our answer would be this. So you can see this is our set bit, not only set bit but lowest set bit, we can say. So now let's see the code. So now let's see the code. Okay, so this is the code. We can see first we join all the element and then we get the rightmost set bit, and based on that rightmost set bit we are grouping them between A and B, and we are also making sure that we join the group as well, and then we are returning A and B. Let me submit the code. So you can clearly say that it is efficient approach as mentioned. And now let's discuss about time and space complexity for this approach. Sorry. So let's discuss time complexity. That would be order of n in this approach, and the space complexity would be order of 1 in this approach. So this is very efficient approach. So I think that's it. If you really enjoyed this session, subscribe to our channel and like the video. Thank you.